Let's start with the third question. The diagram shows the vertical cross section of a surface. A, B, C are 3 points on the cross section. The level of B is h above the level of A. The level of C is 1.5 meter below level of A. Yeah, the particle of mass 0.2 kg is projected up from the slope from it. Now, let's start making the diagram. Here, the mass is 0.2 kg and projected up with the initial speed of 5 meter per second. The particle remains in contact with the surface as it travels from A to C, given the particle reaches B with a speed of 3 meter per second. Okay, so that means when the particle reaches here, the particle attains a speed of 5 meter per second, whereas initially the speed was, 3 meter per second, whereas initially the speed was 5 meter per second. And there is no resistance force. Perfect. Find h. So now what I like to do in these type of questions is, I know that here they have given the height, they have given the velocity, and we have to find the height. So this is a pure question of work energy transformation. And what is being transformed? In some places, GP is being converted to KE. In some places, K is being converted to GP. We'll figure out what is happening where later. But one thing you need to realize is, yes, you have to take the most lowest point as 0 reference. So this will be our ground level, ground. So, and let me write down everything. This is C. So C is at 0. Then this is 0.5. A is at 0.5. And then this is H. So B is at, the total distance will be H plus 0.5. The total distance, this will be H plus 0.5. So now that we have mentioned this here, let us go back to our question. So now what we need to do is find the GPE and the KE at all the points. So what do I mean by that? What I mean is, one second, let me erase this, I'll tell you. What I'm telling you to do is to find the GPE and KE at point A, comma B, comma C. So now let's start with point A. The GP at point, no, first what we need to know is the formula for GPE is mgh. The formula for KE is half mv square. Okay, we'll move forward. At A, the GP will be the mass of the particle is 0.2 into gravity is 10 into the height is 0.5. So the GP is 2 into 1 joule. And what about the KE? The KE of A, the KE of the particle at A will be half into mass is 0.2 into what is the velocity? The velocity is 5. So 5 square. So 0.1 into 5 will be 2.5 joule. Next, at B. What will be the GPE at B? The GPE will be 0.2, which is mass into gravity into height will be h plus 0.5. Now remember, we don't have to write only h, we have to consider this whole thing because this is our ground level. So h plus 0.5, which will give us 2h plus 0.5 because 0.2 into 10 will be 2. And what will be the KE at B? It will be half into mass is 0.2 and the velocity at B is 3. So into 3 square, which is 0.1, 0.1 into 9 will be 0.9 joule. And now finally, let's talk about C. So what will be the GP at C? Because the height at C is 0, so the H will become 0. And so GP is 0 joule. And what about the kinetic energy? That's what we need to know. That's what not we need to find. Do we know the kinetic energy? The particle remains this. The kinetic energy at C. No, we do not know the kinetic energy at C. So the kinetic energy at C will be E. Let us write the speed as m meter per second. Will be half into 0.2 into m square, which is 0.1 m. Now what they have told us to do is, given that the particle reaches B with this, find h. So let me erase everything now. Now understand what is happening here. Initially, the particle had both GPE and kinetic energy here. As it goes up, the particle gains another value of GP and kinetic energy. But however, because there is no resistance force, the energies will remain the same. That means the energy of the particle at A will equal the total energy of the particle at B. And what do I mean by that? Let me rewrite it right here and make it a little easier, a little bit easier for you. Energy at A is equal to energy of B. So that means the kinetic energy at A plus gravitational potential energy at A will equal kinetic energy at B plus gravitational potential energy at B. Now we can simplify this. Kinetic energy at A is 1, no, sorry, 2.5. GP is 1 plus 1. Kinetic energy at B is 0.9 joule. And gravitational potential energy is 2h plus 0.5. Now what we can do is 2.5 plus 1 is 3.5. This 0.19 go there, minus 0.9 upon 2 is equal to h plus 0.5. And this plus 0.5 will become minus 0.5 there. So we simply can put this in the calculator and find the value for h. So the value for h will be minus 0.5 plus 3.5 minus 0.9. Once again, I did a mistake here. 0.5, yes. Okay, and this should be outside. Minus 0.5 plus, and this 2 will come down. So the height is 0.8 meter. So the height is 0.8 meter, and that's your answer here. Next question. It is given that instead there is resistance force and the particle does 3.1 joule of work against the resistance force as it travels from A to C. Find the speed of the particle when it reaches C. Okay. So now we know that as the particle will travel, there will be some resistance force. There will be some force that will stop the object from doing work. So now if there was no resultant force, then the energy at A and the energy at C would be equal. By same logic, why A and B are equal, because there is no other force. So GP and kinetic energy at A would have been equal to GP and kinetic energy of C. But now there is resistance force. So what that means is that the total energy, or let me write it as E only. The energy at A is equal to the energy at C plus some resistance, not resistance, some work done against resistance. So that means the energy at A will equal energy at C, and some work done against resistance will also be there. So what is the energy at A? The energy at A we already found out, that is 2.5 plus 1. So energy at A is 3.5. That will equal energy at C. What is energy at C? GP is 0. Kinetic energy is 0.1 m square. So 0.1 m square plus work done against resistance is 3.1 joule. And what is this m? Remember, we put m meter per second. M meter per second is the velocity of m. Is the velocity of the particle at C. So m square is nothing but the velocity of the particle at C. So we can simply do minus 3.1 upon 0.1 root is equal to m. Therefore, m is equal to 3.5 minus 3.1 is 0.4, 0.4 root of 4. Therefore, m is 2 meter per second. That means the speed of the particle at c is 2 meter per second. Let's move to the fourth question. A cyclist travels along a straight road with a constant acceleration. He passes through points A, B, C. The cyclist takes 2 seconds to travel along each section A, B, and B, C and passes through B with speed 4.5 meter per second. The distance AB is 4/5 the distance of BC. Okay, so let's make a diagram of this now. So there are three sections A, B, and C. And they have told that distance AB is 4/5 the distance of BC. Yeah. And the cyclist is initially here. As the cyclist reaches here, the speed of the cyclist is 4 meter per second. 4.5, my bad. The speed of the cyclist is 4.5 meter per second. The cyclist takes 2 seconds to travel each section. That means the time taken to travel between AB is 2 seconds, and even time taken to travel between BC is 2 seconds. Now, what they've asked us to find is the acceleration of the cyclist. So, how do we find the acceleration of the cyclist? So, I've already written these 5 equations for you. First is S equals UT plus half AT square. Second is V square equals U square plus 2S. Third is V equals U plus AT. Fourth is S equals VT minus half AT square. And last is S equals half U plus V bracket T. So you need to remember all of these 5 equations for your exam. There are three, these first three are already given in the data booklet, MF19. But the last two, if you remember it, it will be easier and more helpful for you. Why? I'll tell you right now. So here the only data we have is time and velocity. So your time, but velocity is not there. So we can't consider this. Um, Here there's no time, so we can't use the second one too. Your time is there, velocity is there. So maybe we can use this. Your time is there, velocity is there, so we can use this. Mm, your time is there and u is there. U is actually the initial velocity, so we can use this also. So we know the second option, equation will not be required at all. And here also we have velocity time, so probably we can use this too. So we'll go ahead. And the question is find the acceleration of the cyclist. So first we can do something for AB. AB will be, and if we use this equation, is equals to Vt minus half at square. And why are we using this? Because we know the V, final velocity, as it reaches B. So we can use this equation and we also know the time. So SAB is V is 4.5, time is 2 seconds minus half. We don't know acceleration, time is 2 square. Therefore, SAB is 9 minus 2A. So we have our first equation right here. And second, we can write an equation for S displacement of BC. And that will be, we have to use this equation UT plus half AT square because in between BC, we only know the initial velocity at B, which is 4.5. So SBC is equal to UT plus half AT square. Therefore, SBC is equal to U will be 4.5, T will be 2 plus half acceleration we don't know, time is 2 squared. Therefore, SBC will be 9 plus 2A. So here we have our second equation. And now we know the correlation of SAB and SAC. SAB is 4 by 5 times of distance of AB. So we know this. So instead of SAB, we can write 4 by 5 SBC. So here instead of SAB, I'll simply write 4 by 5 S of BC. And now let me rearrange the equation. So this equation, I'm gonna copy it right here. So 4 by 5 SBC, and I'm going to take the 2A there. 2A equals 9. So just this 2A went on the other side of the equation. And same this I'm going to copy as it is. SBC is equal to, and This 2a will go there. It will become minus 2a is equal to 9. And let me use my calculator to solve this simultaneous equation. So mod 5 and 1. So 4 by 5, 2, 1 second, AC. Yeah, 4 by 5, 2, 9, 1 minus 2, 9. So the answer for SBC is 10 and A is 0.5. So SBC is 10 and A is 0.5. So what they have asked us for is the acceleration of the cyclist. So here we have our answer. The acceleration for the cyclist is 0.5 meter per second square. Now we move on to the next question, which is find AC. Now what do we mean by AC? The total distance AC. Now right here, we found out SB is 10. That means SB is 10 meters. So we can write here as solved. But instead of writing something like this, we can prove it again actually. So what we can do is, we know that the new acceleration is 0.5 meter per second square. So we can simply use S equals UT plus half AT square. Or we can use V equals U plus AT, V square equals U square plus 2AS, S equals half U plus V bracket T, or S equals VT minus half AT square. So what we know right here is the time taken for this complete thing is 4 seconds, and we know the acceleration too, but we do not know the initial velocity. So what do? We can simply find out two equations, which will be the S. We don't know what is S. We know the initial velocity for BC. Initial velocity for BC was 4.5, time was 2, that's half. Acceleration was 2. No, I'm sorry, acceleration was 0.5, which we found out right here. The acceleration was 0.5 meter per second square. So 0.5 times 2 square. So 2, this 2 cancels out. So distance covered by BCA will be 9 plus 1, which is 10 meter. Now that we know that BC is 10 meter, we also know that SAB is 4 by 5 BC. Let me check that. Distance AB is 4 by 5 BC. AB is 4 by 5 BC, yes. So instead of BC, I can put 10 here. So SAB equals 4 upon 5 into 10. So I can simply simplify this. 4 twos is 8. So the total distance AC is S distance of AB plus distance of BC, which is 10 plus 8, which is 18 meter. And now we are finally done with this question. Moving to the next question. Coplanar forces of magnitude F Newton, 3 Newton, 6 Newton, 4 Newton act at a point B. Given that alpha is 60 and that the resultant force of the four forces in the direction of the 3 Newton force, find F. Okay, so what they are telling us is that the resultant force is in the direction of the 3 Newton force. That means the resultant force is in this direction. That means the upward forces somehow cancel out to be zero. And what do I mean by that? By that, I mean, before doing anything, let us first resolve these forces. So let us consider this 4 Newton force first. So this is 4 Newton and this is 30 degree. So the upward force will be, according to sine rule, sine 30. If this is x, it will be x by 4, which is 4 sine 30. So this x will technically be 4 sine 30. Similarly, if we use cos, we will get 4 cos 30 here. So we are done with this. So let me cancel this out. This is 4 sine 30 and this is 4 cos 30. Let me write a line in here. We'll put all the vertical forces here, and we'll put all the vertical forces will be here and all the horizontal forces will be here. Okay, now we'll go to the next one, which is this F Newton. So this F Newton, this alpha is technically 60 degrees. Why? Because they have mentioned it right here. So if we draw the diagram for this now, so this is 60 degree, this is F Newton, and this is the upward force, and this is the force to the right. So if I put this as x, so I'll get sine 60 is equal to x upon f. So this f will go right here and this will become f sine 60. So x is f sine 60, and so the upward force is f sine 60. Similarly, the force to the right will become f cos 60. If we use cos here, if this is y, then cos 60 is equal to y upon f, and this f will go up and it will become f cos 60. I hope you are sure with this, and we have F Newton done. And now the only two remaining forces, these are quite simple because in this 3 Newton force, there is no force that will go to the up or down. So this will simply be 3 Newton, and this will downward force will simply be 6 Newton. And now what they have given us this is the resultant of the four forces in the direction of the 3 Newton force. That means some resultant force will acting here. And that means the vertical force in the vertical force, the resultant force is zero. Why? Because the resultant force is in the direction of the 3 Newton force, that is to the horizontal, this one. So that means if there is a force acting horizontally, it will have no impact whatsoever in moving the object from up to down. So that means the vertical resultant force is zero. And now we can find that what is the F by this equation. Now this is an upward side arrow, this is upward side arrow, this is a downward side arrow. So what we can do is 4 sine 30 plus f sine 60 is equal to 6. Then what we can do is f sine 60 is equal to 6 minus 4 sine 30. And this sine 60, we can put it down upon sine 60. So the value for f will be 6 minus 4 sine 30. 1 second, mod 1. 6 minus 4 sine 30, bracket close, upon sine 60. So the answer is 4.62 Newton. So the force F is 4.62 Newton. Now what they have asked us to find is the, given that alpha is 60 and the resultant force is find F. So here is our answer. F is 4.62 Newton. Now moving to the next question. Given that said that the four forces are in equilibrium, find the values of F and alpha. So now in this case, we are not given the value of alpha here. So right here, 1 second, let me erase this. Previously, we knew that alpha is 60, but now we don't know what alpha is. And what did alpha correlate to? Alpha correlated to the F Newton force. So here, instead of sine 60 and cos 60, what we'll have to write is sine alpha and cos alpha. Yeah. And now we do not have this vertical resultant force equals 0. Why? Because they have told us, given that instead the four forces are in equilibrium, that means this is not the case. And so what we are going to do is we are going to equate both of them. So we'll use the same equation for this, but instead of sine 60, we'll use sine alpha. So 4 sine 30 plus f sine alpha. 4 sine 30 plus f sine alpha is 6. Now, as you can see, we cannot solve the equation directly because we have two unknown variables. But we also have a second equation, which is 4 cos. Now this is in the left side, this is on the right side, this is on the right side. So we can take 2 on the right, which is f cos alpha plus 3 Newton is equal to So the forces on the right will equal forces on the left, and the left only forces 4 cos 30. So now that we have two equations, we can make sine alpha and cos alpha the subject. So now moving with this forward, f sine alpha will become 6 minus 4 sine 30. And moving with this, f cos alpha will become, no, I wrote 30 by mistake, this should be alpha. F cos alpha should be 4 cos 30 minus 3. Now what we can do is we can divide this. And what do I mean by this? What I'm saying is 4 sine alpha upon 4 f cos alpha, not 4, I meant f. So f sine alpha upon f cos alpha will be 6 minus 4 sine 30 upon 4 cos 30 minus 3. Now this f and s cancel out, and we know all sine alpha and cos alpha is tan alpha. So 6 minus 4 sine 30 will be 6 minus 4 sine 30. The answer is 4. So 4 tan alpha is equal to 4 upon 4 cos 30 minus 3. 4 cos 30 minus 3. So the answer is minus 3 plus 2 root 3, or 0 0.4641. 0.4641. Therefore, alpha will be tan inverse of 4 upon 0.4641, and that is tan inverse of 4 upon answer. Answer is 83.8 degree, 83.4 degree. So alpha is 83.4 degree. And now we are the value of A we have found. And what about the value of our F? So we know f sine alpha is 6 minus 4 sine 30, and 6 minus 4 sine 30 is 4. So f sine alpha is 4. F sine alpha is 4. Why? Because f sine alpha is 6 minus 4 sine 30, and 6 minus 4 sine 30 is equal to 4. So f sine alpha equals 4. Therefore, f sine 83.4 equals 4. Therefore, f is 4 upon sine 83.4. Let me write it properly. Not 38. This should be sine 83. Sine 83.4. Okay. So the value is 4 upon sine 83.4. Bracket close. The answer is 4.03 Newton. And that is our answer. Okay, so next question is, at the instant when the brakes were applied, the car has a speed of 22 meter per second. At the instant, at this instant, the car is 17.5 meter away from a stationary van. Let us do a diagram for this much in order to process it. 1 second, not a good line. Yeah. Eh? Yes. Mm, so this is a car, and car has the speed of 22 meter per second, not 72, 22. And that is 17.5 meter away from a stationary van. So once again, this is 17.5 meter away from a stationary van. The stationary van is right here. And show that the car hits the van at a speed of 8 meter per second. Now, some other information we know is that the deceleration of the car is minus 12 meter per second. I'm sorry, the deceleration is 12 meter per second. The acceleration is minus 12 per meter per second. So what we can do is we can simply use the formula v square equals u square plus 2as. We know s is 17.5, so s is done. We know acceleration minus 12. We know u 22. We just need to find v. So again, I'll write it down, v square equals u square plus 2as. We don't know v square, we have to find v square. U square is 22 square plus 2, acceleration is minus 12, and S is 17.5. Therefore, V equals root of 22 square minus 2 into 12 into 17.5. And so the answer for this is, once again, let me remove my calculator. Root of 22 square minus 2 into 12 into 17.5. So the answer is 8. Yes, so the velocity at which it will hit the car is 8 meter per second. We are done with this question. Let's move to the next question. After the collision, the van starts moving with a speed of 5 meter per second. Wow. And the car and the trailer continue to move in the same direction with the speed 2 meter per second. This is also very easy question. Yeah, this is the trailer. This is the car. This is the van. Now assume that right now they just collided. And after that, after the collision, the van starts to move with a speed of 5 meter per second. And the car and trailer continue to move with a speed of 2 meter per second. So what we can do is we can use the initial momentum is equal to final momentum. And I hope you guys know the formula for momentum. Momentum is equal to mass into velocity. So initial momentum of the car and trailer, which were moving at the speed of 8 meter per second as they hit the car. So the mass of the trailer and the car is 1600 and 700. So 1600 plus 700 into velocity was 8 is equal to final momentum. That is the velocity of the car and the trailer, which is 2 plus the velocity of the van. What is the mass of the van? The mass of the van is not mentioned and we have to find that. So the mass of the van into velocity of the van is 5. So now we can do some basic calculations. 1600 plus 700 will be 2300 into 8 minus 2300 into 2. Answer upon 5 is equal to m. So the value for m will be 2300 into 8 minus 2300 into 2. Answer upon 5. So the mass of the van is 2760 kg. And here we have our final answer. And we are done with this question. Let's start with the sixth question. On a straight horizontal test track, driverless vehicles are being tested. A car of mass 16,000 kg is driving a trailer of mass 700 along the track. Okay, so now let's start making the diagram. Make the diagram here. So on a straight road, a car of mass 16,000 kg. So let's draw a car. This is a car. Mass is 16,000 kg. Is towing a trailer of mass 700 along a track. So with this green pen, I'll draw tow bar and is towing a trailer. Okay. So this is your trailer right here. Trailer. The mass of the trailer is 700 kg. Brakes are applied, resulting in a deceleration of 12 meter per second. Now, or initially, what you need to understand is the car and the trailer will be moving like this. Now that the brakes are applied, the deceleration is 12 meter per second. That means that acceleration in this direction will be minus 12 meter per second square. So now that we are clear that because the deceleration of 12 meter per second square is written, that means acceleration will happen in minus 12 meter per second square on the right. The braking force acts on the car only. Okay, we'll draw the braking force also now. So this is the braking force and this is acting on the car. So braking force. In addition to the braking force, there are constant resistance forces of 600 Newton on the car, 2 Newton 100 on the trailer. Okay, so 600 Newton on the car will look something like this. 600 Newton on the car and 200 Newton on the trailer. Find the magnitude of the force in the tow bar. So by the magnitude of the force in the tow bar, what they're simply asking us to find is the tension. So now that we are free body diagrams, let's make equations for the car and trailer. But first you need to realize is F resultant is equal to mass into acceleration. And the second thing is finding out F resultant for both. So F resultant for trailer and F resultant for car. So F resultant for trailer will be there are only two force acting on the trailer, that is the tension force, this one, and the 200 Newton force. So F resultant will be tension minus 200. And by the first equation, we know that F resultant equals mass, which is 700, and acceleration we already discussed is minus 12. So minus 12. Therefore, 700 into minus 12 is T minus 200. So T will be 700 into minus 12 plus 200. Therefore, the value for tension we got here is 700 into minus 12 plus 200. So the answer is minus 8200 Newton. But now what they have told us is to find the magnitude. Now magnitude means the only value. So the answer will simply be plus 8200 Newton. Now even though we have the answer, let's find out what will be the value of T if we found out from the car. So now here we'll make the free body diagram again. We have a few values to understand. First will be the braking force and the 600 Newton and the tension are all acting backwards. So here the F resultant will be minus T minus braking force and minus 600. And what is F resultant mass into acceleration? This is 1600 into minus 12. So 1600 into minus 12 is equal to minus T minus BF minus 600. Now we can get rid of the negative signs on both sides. So we'll get 1600 into 12. Let me just put that in the calculator. 1600 into 12 is 19200. So 19200 is equal to T plus braking force plus 600. Now if 600 goes there, what we'll get is 19200 minus 600. That is 18600. So 18600 is equal to tension plus braking force. But now because we do not know braking force and there are two unknowns in this equation, we cannot find what tension is. So this is the answer 8200. Hence, if you had first tried car, you would have not gotten the answer. And next time when you solve the paper on your own, make sure that to check out that there is only one unknown variable. For example, 200 Newton and T. There was only one unknown for trailer. But for the car, there were two unknowns, this T and braking force. So that's where the problem comes in. Next, yes, now the F resultant for the car, copy it all down here because we have to find a braking force. And because we already have summed up between 600 is equal to tension plus braking force. And I have a question for you. Your tension is written and we know the value for tension is 8200. But is it actually the value 8200? No. Why? Because if you remember here, I will do this for you again. I'll write it down in fact because this is very important. 700 into minus 12 plus 200. This was tension. And if I put that in the calculator, if I trying to find it, 700 into minus 12 plus 200. This was minus 8200. The real value for tension is minus 8200, not plus. We wrote plus 8200 Newton here because it was asked in the question to find the magnitude. What is the magnitude exactly? The magnitude means if I tell you to find the magnitude of minus 3, the answer will be plus 3. If I tell you to find the magnitude of minus 1076, the answer will be plus 1076. So that's what they asked in the question. But that's not the real value for tension. The real value for tension is minus 8200. So now in this T, we'll input the real value for tension, which is 18600 equals minus 8200 plus breaking force. Therefore, we can find the breaking force, which is 18600 plus 8200. And the answer, let me put that in the calci. No, we can do it mentally only. 18, 18, 26, 26, 800 Newton. So the breaking force is 26800 Newton, and that is our final answer. Let's move to the seventh question. A particle moves in a straight line through point O. The displacement of the particle from O at t time is s meter, where s is this, and for time t0 to 6 and for time t more than 6. Find the value of t when the particle is instantaneously at rest during the first 6 seconds of its motion. So now what do they mean by this? The particle is instantaneously rest means the velocity of the particle should be 0. And now here we have a displacement time graph, S time graph. And from a displacement time graph, if we want a velocity time graph to find the velocity at 0. So what we need to do is we need to derivate the function, or we need to differentiate the function. So we know S equals t square minus 3t plus 2. So if we derivate this function, this is derivative of t square minus 3t plus 2, then we'll get 2t minus 3. Therefore, which is equal to the velocity. So the velocity will equal not 3, but 2t minus 3. So velocity is 2t minus 3. And we have to find the value of t at which v is 0. So inputting 0 equals 2t minus 3. Therefore, 3 equals 2t. So time at which velocity is 0 is 3 by 2 seconds. Let's move to the next question. At t equals 6, the particle hits a point P and rebounds. At t equals 6, the particle hits a barrier at a point P and rebounds. That means initially till 6 seconds it was moving, and then it is hitting a barrier at the 6th second. Find the velocity with which the particle arrives at P and also the velocity at which particles leaves P. So we have the displacement time graph here for both of these. For one of these, we derivated and found the velocity time graph. So what we need to do simply is for time between 0 to 6, the velocity time graph is 2t minus 3. So at time 6, the velocity will be v equals 2 bracket 6 minus 3. 6 2s are 12, 12 minus 3 is 9. So velocity as it arrives the barrier, let me draw a barrier with a different color. So this is a barrier. The particle just approached the barrier at 9 meter per second. And now we'll see at what speed does it rebound. So now how do we do that? We have another equation, which is S equals 24 upon t minus t square upon 4 plus 24. So let us write that down. S equals 24 upon t minus t square upon 4 plus 25. So in order to find the velocity, we need to derivate this equation, or we need to differentiate this equation. So 24 upon t can be written as 24t raised to minus 1. So I'll write that down, minus t square upon 4 plus 25. Now if I derivate this equation, I will get 24 into minus 1 t raised to minus 2 minus 2t square upon 4, and this square will become will become 1, and 25 becomes nothing. So v equals minus 24 upon t square minus t by 2. And at t equals 6, we'll have to input it again. So v equals minus 24 upon 6 square minus 6 upon 2. And now if I put this in the calculator, the velocity that I'll get is minus 24 upon 6 square minus 3 because minus 6 by 2 is 3. So the answer is minus 11 by 3 and minus 11 by 3 meter per second. And what is minus 11 by 3? M is minus 1. And what is minus 11 by 3? Minus 11 by 3 is 3.667. So that means the particle rebounds at 3.667 meter per second. Why did we get a negative answer? Because initially the particle was moving in the direction to the right. And then when it rebounded, it started moving to the left, which is the opposite direction. Hence, the sign changed that it became minus 3.667 question. And the last question is find the total distance traveled by the particles in the first 10 seconds of its motion. So for that, we'll need to draw displacement time graph. So what is the displacement time graph for the first one? S equals t square minus 3t plus 2. And now we know that the maximum point of the graph is at t equals 3 by 2. And why do we know that? Because what we technically did is find the maximum point or the minimum point, whatever it is, we'll find out maximum or minimum point of the graph by derivating and equating it to 0. So when we put t equals 0, we got the answer as 3 by 2. So at 3 by 2, what is the value for displacement? So let's find out. X square minus 3x plus 2. And solving the x for 3a by 2. So the answer is minus 0.25. So that means the displacement when 3x is 3 by 2 is minus 0.25. And the c intercept is 2. That means somewhere here 2. And so the graph will go something like this. And what is the velocity at 6? Sorry, what is the displacement at 6? So let's find that to solve 6 because this graph is only till 6. So let me draw 2 over here and 20 over here. So that means the graph starts from here from 2 and ends at 20, where this is 6. Time is 6. And now, what about the time? What about the displacement? When this is 6, when time is 6, what about this displacement? So let us write this down now. 24 upon x minus x square upon 4 plus 25. So at 6, the value is 20. So both are equal at 1 second. This is only till 0 to 6. And the next one, which is 24 upon t minus t square upon 4 plus 25. So this is from 6 to 10 because they have told us to find the first 10 seconds. So even at t equals 6 here, we are getting the value of 20. And now what about the value for 10? Solve value for 10. The answer is 2.4. So that means somewhere here between 2 and 20. At 2.4, the graph will end up somewhere here. So what they have asked us to find is the total distance. So now I've made a better diagram for you guys to understand. Now what the question is, is to find the total distance traveled by the particle in the first 10 seconds. So first, the distance traveled will be this between time 0 to 1.5 seconds. The distance traveled will be from 2 to 0.5. So the 1 second, the distance will be 2 plus 0.5 plus this is between time 0 to 1.5 seconds. Then next from 1.5 to 6 here, the total distance being traveled is from 0.25 to 20. That is 0. This should be 0.25. Yeah, 0.25 to 20. This is between time 1.5 to 6 seconds. And then at last, this distance is from 20 to 2.4. So this will be 20 minus 2.4. This is between time 6 to 10 seconds. 6 to 10 seconds. Yes. So the total distance that would be 2.25 plus 20.25 minus 17.6. Now if you put this in the calculator, 2.25 plus 20.25 minus 17.6, not minus, plus 17.6 is 40.1. So the total distance traveled is 40.1 meter. And now if you don't understand what did I do here, this is the displacement time graph. And now if I tell you, if something has been displaced 5 meter to the right, that means the distance traveled is 5 meter. So that means when the ball was here, let us assume this as the original position O. This, let's assume the ball is moving in a straight line in this box. So this is the starting position O, but the ball is already 2 meter above ahead. So let this be the 2 meter ground. So the ball is initially here, and then it is going backwards and such that it is 0.25 meters below the original position. So the ball is first traveling this much. So this is minus 0.25. And then, so this distance total traveled will be 2 plus 0.25. Then the ball from minus 0.25 is going to 20 meters. So let us write 20 meter here. So this is the first round. And in the second round, the ball will travel from minus 0.25 to 20. So this in this second round between time 1.5 to 6, the ball will travel 20 plus 0.25 meter. And in the last and third round, the ball will travel from 20 to 2.4 meter, somewhere here. So this is the third round. So if you calculate the distances of this line, well, like what is the length of this plus what is the length of this plus what is the length of this, your total answer what you will get is 40.1, and hence the total distance traveled 40.1, and the total distance traveled by the particle is 41 meter. And that's how we end this question and this paper.